Welcome to section 1.3 trigonometric functions. This is going to be a really short review of just a few of the topics in trigonometry that you'll need to remind yourself of to be successful here in the calculus course. So there are three objectives here in this video. At the end of this video, I'm hoping that students will know and be able to demonstrate 1, how to convert between radians and degrees. 2, how to complete and use the unit circle. And 3, how to recall and use some of the trigonometric identities or trig identities. So let's look at these three objectives. We'll start with the first, being able to convert from a radian to a degree or a degree to a radian. Could we start with an even more basic review, and that's the review of the formula for the circumference of a circle. You should recall that the circumference of a circle is the distance all the way around the circle. So if the radius of the circle is given, the circumference can be found by multiplying 2 times pi times that given radius. The radius is the distance from the center to the outside. So if, for example, if we had a radius of 1 foot, the circumference would be 2 times pi times 1 foot, or 2 pi feet. What does that mean? The circumference, the distance around, means if I had a piece of yarn and I held the yarn here and traced it all the way around my circle, wrapped it around the circle, then I took that piece of yarn and stretched it out, it would be 2 pi feet long. If the radius was 1 foot, it's a pretty big circle, much bigger than what I have pictured. But if the radius was 1 foot, then that circumference, the distance all the way around, would be 2 pi feet. Well, the next step is to recognize that we also have an angle measured here. So if I looked at this angle inside here, that angle all the way around could also be measured as 2 pi. And in this case, it's 2 pi radians, because radian is a measurement for an angle. You may be more familiar with measuring an angle in degrees, and you probably recall that the angle measurement all the way around is 360 degrees. So do you see the connection we can make here is that 360 degrees and 2 pi radians are equivalent. We can use this fact that 2 pi radians is equal to 360 degrees to write what we call a unit fraction. We could write it 2 pi radians over 360 degrees, and that gives us 1 unit, or 1, because 2 pi radians and 360 degrees are the same. It gives us a unit, a 1 fraction. So this fraction is equivalent to 1, and because 1 is a multiplicative identity, that means we could multiply this fraction times any number, and it doesn't change the identity or the value of that number. So that's what's so powerful about a unit fraction. To get a better unit fraction here from the 2 pi over 360, I'm going to simply reduce by 2. 2 divided by 2 is 1. 360 divided by 2 is 180. So I'd get pi over 180 radians to degrees. That's would be the same if I flipped that. I could put the degrees on top and the radians in the bottom. When the degrees is in the numerator on top, and the radians is in the denominator, on bottom we get 180 over pi. So these two unit fractions are equivalent unit fractions. They're both equal to 1. Pi over 180 or 180 over pi. So let's look at an example of how we can use that unit fraction to convert radians to degrees or degrees to radians. For an example, let's start with 3 pi radians. If I have 3 pi radians and I want to convert that to degrees, I have to decide, am I going to use 180 over pi or pi over 180? And I'm going to help you understand that by writing the units in here. And when I write the units, it becomes very much more clear that we want to use the 180 over pi, because what we want is for the radians to reduce or divide out. The only way I can get rid of that radian with the 3 pi is to put the radian in the denominator for a unit fraction. So because we're trying to get rid of the radian and end with a degree, we want to divide out the radians. So that's how I know that the radians needs to be in the denominator. So that's why pi is in the denominator. And if pi is in the denominator, then the 180 degrees must be in the numerator. So all I've got to do now is multiply 3 pi times 180, and that gives me 540 degrees. You know, just a quick review of this. I want to look at the really good problem solving steps that we have. You know, that last step is always to check or look back. So just a quick look back. If I went all the way around the circle, that would have been 360 degrees, and that would have been 2 pi. 3 pi is going to be all the way around and then halfway around. So I could check this and verify, yes, 360 plus 180, that gives me the 540 degrees. But 3 pi radians equivalent to 540 degrees, that is certainly falls into what we'd expect it to be as an estimate. But then we can do it even precisely by saying 360 degrees plus 180 degrees. However, not all of them are quite as obvious. So you want to still embrace this process. Make sure that you can use a unit fraction to determine the conversion. Let's try another one. We'll go from 29 degrees to radians. So do you see why I'm going to put the 180 in the denominator? Because I want this degree in the 29 to reduce with a degree. So I've got to have the degrees in the denominator. If the degree is going to be in the denominator, that's the 180. So the unit fraction I'll use this time is pi radians over 180 degrees. The radians is left once the degree over degree divides out. So I'm going to do 29 times pi divided by 180. Now that 29 over 180 doesn't reduce, so I could simply leave it like this, 29 pi over 180 radians. If you wanted to get an estimate on your calculator, we could do 29 times pi divided by 180 and get that this is approximately 0.5061 radians. But the better answer is the precise 29 pi over 180. Let's do one more example before we move on to the unit circle, and that's 5 1/10 of a radian. This example tends to throw students off, which is why I wanted to use this one. And again, how do we start the problem? You write the 5.1 radians over 1 and then multiply by the unit fraction. The unit fraction we want here is going to put the radians in the denominator, so pi radians in the bottom, so that leaves the 180 degrees on top. But when I've written it like this, I can see that the radians divides out. So what do I have? I have 5.1 times 180 over pi degrees. Now, this throws students off because it has a pi in there, and so sometimes students look at that and think, oh, I must have done something wrong. But no, this is correct. 5.1 times 180 is 918. 918 over pi degrees. And yes, pi is just a constant. It's just a number. So you could have a degree measurement that has a pi in it. You could also take this and divide 918 divided by pi to get an approximation if you feel a little better about that, but it's approximately 292.2 degrees. But it is okay that our answer had a pi. Don't let that throw you off. Throughout this work that we're going to do in calculus, I hope that you'll become more and more and more comfortable with pi. Pi is just a constant. It's a constant that's approximately 3.14, but it's not equal to 3.14. But throughout our semester together, you'll want to become more and more comfortable with pi simply as a constant. Let's move on to number 2, use and complete, maybe is a better word, the unit circle. Let's start with the end in mind. The end in mind, what is the unit circle all about? The unit circle is all about being able to fill in this chart. You need to be able to state very quickly, easily, the sine of 30 degrees. The sine of 30 degrees is simply 1/2. The cosine of 30 degrees is simply the square root of 3 over 2. And then if I have the sine and the cosine, I can easily find the tangent. Tangent is sine over cosine, or sine divided by cosine. So 1/2 divided by square root of 3 over 2 is the same as 1/2 times the reciprocal. So I get 1 over the square root of 3. By the way, don't be concerned with rationalizing a denominator. You're mature enough now as a math student to have a radical in the denominator, and that is perfectly okay. So don't worry about a radical in the denominator. But where did I get these numbers? How did I know that the sine of 30 is 1/2, the cosine of 30 is square root of 3 over 2? Very easy using the unit circle. 45 is even easier, or the pi over 4, because 45 degrees is equivalent to pi over 4 radians. We get a square root of 2 over 2, square root of 2 over 2. The ratio of those two, or when I say the square root of 2 over the square root of 2 over 2, when we divide those, we just get a 1. But it's really easy to fill this chart in once you know the unit circle. And let me be clear that you understand, no calculator. You need to be able to do this from memory. Well, let me say you need to be able to do the sine and cosine from memory. And then you need to be able to use those sine and cosine to get the tangent. How do we do that? It's with the unit circle. So as I mentioned, when we stepped into this part, the unit circle part, I said, let's start with the end in mind. The goal is really to be able to fill in this chart, to know these principal angles, sines and cosines, without the assistance of technology. Taking a step back from that, how do we accomplish that? You could just memorize a chart, or much better, you could become familiar with this unit circle. The unit circle can sometimes be a challenge to some students because you look at it and think, how am I going to memorize that whole thing? Well, let's start with how to read it, how to read the unit circle, and then from there we'll look at how to develop the unit circle, or how to create the unit circle, how to fill in all those numbers in the unit circle. So how do we read it? The way we read this is that each of these ordered pairs, these items in parentheses, those are an ordered pair for a point that lies on a circle whose radius is 1. What is a unit circle? It's a circle whose radius is 1. And then each of these is simply the ordered pair of one of those points on the circle. If I looked at this point for 225 degrees, which is equivalent to 5 pi over 4 radians, that means that from here to here was 225 degrees, equivalent to 5 pi over 4 radians. And the way I read this is that the cosine is the x coordinate. So the cosine of 225 degrees is negative square root of 2 over 2. That's how we read it. So go ahead and pause the video and make sure you can fill in this chart for sine and cosine, and then use the fact that tangent is sine over cosine to fill in the bottom of the chart. But you should be able to do that. If you aren't able to complete the unit circle yet, let me tell you, regardless of how much struggle you may have had with it before, it really is as easy as 1, 2, 3. And because 1 is less than 2 is less than 3, the square root of 1 is less than the square root of 2 is less than the square root of 3. And because that inequality holds, if we divided them by 2, the inequality still holds because it's a positive 2. It wouldn't hold if we had a negative 2. If it was dividing by a negative, then the inequality signs would reverse. But because 1 is less than 2 is less than 3, we have that 1 over 2 is less than the square root of 2 over 2 is less than the square root of 3 over 2. In other words, if we had these 3 lines, we could call the lines a small line, this pink one, a medium line, that'll be our blue one, and a large line, that's the green one. I have them horizontal here. We could also write them vertically. Small, medium, and large. Or if you're a Starbucks fan, let's call the small a tall. The medium line is a grande. And the large line is the venti. It really is that easy, just small, medium, and large. We'll think of the 1/2 as a small, the square root of 2 over 2 as a medium, and the square root of 3 over 2 as a large. And look at how those lines appear in the unit circle. All I've done here on the right is zoomed in to this quadrant 1 of the unit circle. And we can see we've got the long line goes out to this length or to this height. If we're getting to these ordered pairs, right? If we're looking for the x and y of these ordered pairs, the x is long and the y is small. Or the x is medium and the y is medium. Or the x is large and the x is the short, the pink one here. X is small and y is large. So all I have to do is know which, is it a short line? Is it a medium line? Is it a long line? And then choose 1/2 square root of 2 over 2 or square root of 3 over 2. Let's try that on the unit circle. Let's put these ordered pairs in. If I wanted the ordered pair for this point on a unit circle, so the length is 1, then x is 1, y is 0. If I want the ordered pair for this next line, here's the X, it's a large. Here's the Y, it's a short. So we have square root of 3 over 2 for the X or the cosine, and a short, a 1/2 for the Y. And then we have a medium, so square root of 2 over 2, square root of 2 over 2. And we have a short line, long line, so a 1/2, and then a square root of 3 over 2. All I'm doing is finding the ordered pairs for these points on the unit circle. This one's an easier one because it's just X is 0, Y is 1, because the radius of this unit circle is 1 unit long, right? So to get the ordered pairs, all I really need is these 3 for the quadrant 1. The 1, 0, 0, 1 are more obvious. And then once I have the first quadrant, I can find the values for the other quadrants by just using positive and negative. The X's over here in quadrant 2 are all negative, and the Y's are all positive. And this one's a 0. And then here in this third quadrant, we're negative, negative, but we're just going to mimic the values that we already have, but change their sign as appropriate. And then the last quadrant here, the X's are all positive, and the Y's are all negative. And that's all we need. This first quadrant leads us to all the other quadrants. So if you can master the first quadrant, you can master the whole unit circle. So that gives us all the ordered pairs around the unit circle. The only thing left is to be able to write in our degree measurements. So we could start here with 0 degrees or 0 radians, and that's equivalent to 2 pi radians or 360 degrees. If we went all the way around the circle, it'd be 2 pi radians or 360 degrees. We can see from this, from the black line to the black line, that angle measurement is 90 degrees. And if we went all the way around to this point, so halfway around the circle, it'd be 180 degrees, which is equivalent to half of 2 pi radians or pi radians. This halfway mark, the 90 degrees, if it's half of pi, would have to be half of pi radians or pi over 2 radians. We could do this blue line next because it's half of 45 degrees or half of a half. So 45 degrees is equivalent to pi over 4 radians. And then we could see that these are 30 degrees each. The red lines are 30 degrees each. So this line would represent 30 degrees. This angle would be 60 degrees. And it's 1/6, if we count how many sections there are up through pi, it's 1/6 radians or 2/6. Now 2 pi over 6 I can reduce by 2 to get pi over 3. But I could continue wrapping all the way around the unit circle really quickly. I'll show you how I do that. I start with these, I start here at the 0, and then I do these quarters. So 45 degrees plus 45, so 45 times 2 is 90, 45 times 3 is 135. You could even pop that into a calculator. 45 times 4 is the 180, 45 times 5 times 6 times 7 times 8, and you'd get each of these values. And then for the radians, I start with 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, and then back to 8/4, and you just have to reduce as you go. And then do the same thing with 1/6. 1/6 pi, or pi over 6, 2/6 pi, which remember that reduces, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, and we're back to 12/6, or when we reduce that, 6 goes into 12, so just 2 pi. And that's the unit circle. It does take some practice, so try it. You could get a copy of this. You could pause the video, take a picture, or you could get a copy of this from Blackboard. I have it posted there for you. But the best way to review this is to practice it, ask some questions, and we'll get to the point where everyone is comfortable doing that unit circle. Really quickly, let's breeze through goal 3. You may need to pause the video to write some of this, but just some real basic trig identities that you must go back to review are adjacent over hypotenuse, or opposite adjacent and hypotenuse values. And then if we made these x's and an r for the radius and the xy, then you need to be able to write each of these identities. And then especially here, I'm going to highlight that you need to review the reciprocal identities and the Pythagorean identities. These are going to come up again and again, especially these Pythagorean identities. And if they're not familiar for you, you're going to quite likely struggle to get through some examples when you are doing some of the calculus. If you don't know those identities, it could really come back to hurt you. Questions. If you have questions about this video, please jot them down, bring them to class with you, or you could even try posting it on the Blackboard discussion board, and it's possible that a classmate could help you even before class. But don't let your questions fall away and get lost. Please ask your questions either in class or on the Blackboard discussion board, or come meet me during my virtual office hours, or send me an email. I'm here to help you, so let me know what part of this video was unclear. And I look forward to seeing you in class as we'll discuss these topics further.